This video will cover the T.1.A notes, which is our intro to trig. You do a little bit of trigonometry in geometry, so remember it has to do with triangles. Here we have a list of all kinds of different applications of trig, and in this video we're going to talk about just the basics. The first thing we're going to look at is an angle in the coordinate plane. Okay, and when we do that, we are going to be looking at angles in what's called standard position. So what that means is the vertex of the angle is going to be at the origin at 0, 0. And then we have what we call the initial side. So the first ray is going to be on the x-axis in the positive direction. So this would be the initial side. Alright, and then the angle can be anywhere, right? Like I could draw an angle here. I could draw an angle there. I could draw an angle anywhere I wanted. That is going to be what we call the terminal side. Okay, so that second ray. Alright, so initial side always on the positive x-axis. Terminal side can be anywhere. We also are going to look into the direction. Okay, so if I have a positive angle, alright, positive angles go counterclockwise. So when you see angles drawn, what you're going to see is you're going to see the rays, and then you're also going to see an arrow. Okay, and so if the arrow goes up or in a counterclockwise direction, that would be a positive angle. Alright, if the arrow goes down or in a clockwise direction, this would be a negative angle. Alright, so positive goes up or counterclockwise. Negative goes down or clockwise. Okay, we have two different units of angle measurement. So degrees you are familiar with, and remember a full circle would be 360 degrees. So if I drew an angle here, alright, that would be a 90-degree angle. If I drew one here, that would be a straight line, which is 180 degrees. Alright, and both of these, we're going in a positive direction here. So this way, alright, this one's from here, that way. If I drew an angle down here, that would be 270 degrees. Alright, and then a full circle is, whoops, I need a different color. Of course, 360 degrees. So that you are familiar with. This second unit of measurement is called radians. Alright, so think of it like feet and meters. Okay, two different units, but they both measure distance. So degrees and radians, two different units, but they both measure angles. Alright, where a radian comes from is if you remember from geometry, we can find arc lengths. Okay, so if I draw an angle so that the arc length on the circle is the same as the radius, that angle measures 1 radian. In the description on the video, there's a link to a GIF that you want to go watch so that you can get a better understanding of what a radian is. In radians, a full circle is 2 pi. Okay, so if I went all the way around, that would be 2 pi radians. Alright, so if a full circle is 2 pi, then a half circle would be pi. Alright, which means that this would be pi over 2, okay, or 1/2 pi radians. And then down at the bottom would be 3 pi over 2. Okay, so radians, degrees, two different units of measurement. You have to be comfortable with both of them because you're going to be asked to use both of them. Okay, so here we have some angles that we're going to find the measurement of. Anytime your given information is in degrees, your answer should be in degrees. If your given information is in radians, your answer should be in radians. So we're going to start here, and I'm going to deal with full circles as much as possible. So if I look at this arrow that's drawn, I have one full circle, that's 360 degrees. Alright, then I can go around a whole nother full circle, so that's another 360 degrees. And then I have to figure out what this little red piece is right here. They tell me that from here to there is 135. So I have to figure out what this missing piece is. Well, if this is 135, if I went all the way down back to the x-axis, that would be 180, right? So 180 minus 135 would give me this little missing piece. Okay, so that means this little red piece that I have left here has to be 45 degrees. 180 minus 135 would be 45. Okay, so again, if this whole thing, so I'm going to draw it in pink, if the whole pink thing is 180, and this piece is 135, then the 45 has to make up the difference. Okay, so this angle, the whole red little arrow that's drawn here, is 360 plus 360 plus 45. Okay, so that is 765 degrees. Alright, and the arrow starts and goes up or counterclockwise, so it is a positive 765 degrees. Alright, now I'll do one in radians. The process is the same, so I'm going to deal with full circles as much as I can. Alright, so there's a full circle. In radians, that is 2 pi. Alright, there's another full circle, so another 2 pi. Okay, now I have another half circle, so I can add one more pi. Alright, and I have to figure out what this missing piece is here. Again, they give me this piece is 5 pi over 6. So, again, just like with there, if I went the whole way, that would be a half circle. That would be pi. Right? But I know that the green piece is 5 pi over 6. So if I did pi minus 5 pi over 6, that would tell me what my little missing piece here is. Alright, so pi minus 5 pi over 6. If you're going to do this in your calculator, ignore the pi's and then put them back in your answer. So in the calculator, I would type in 1 minus 5/6. It would give me 1/6, so my answer is pi over 6. So this little piece here is pi over 6. Alright, so I have to add that to my running total over here. Alright, so 2 pi plus 2 pi plus pi, that's 5 pi plus pi over 6 is a total of 31 pi over 6. Alright, radians are always going to be in fractions, improper fractions, not mixed numbers, so fractions with pi in the numerator. Alright, you try these other two examples. Pause here and then I'll have the answers for you when you get back. Okay, those should be your measurements for those two examples. Remember, you have to take into account direction, so this one goes down or clockwise, so it's negative 100 degrees. This one is going up. Alright, so 17 pi over 4 radians. Okay, next we have coterminal angles. Alright, coterminal angles are angles that have the same terminal side but a different measurement. So they end up in the same place, but their measures are different. So if I had this angle here, we'll say that it is 100 degrees. So I have a 100-degree angle. I could also start in the same place, alright, go around a full circle, and then come back and end at that same place. So they would have the same terminal side, alright, but this time that angle would have a measure of 360 plus 100, so it would be 460 degrees. Alright, I could also go in the negative direction, so I could go from this angle and go around this way to that side. So again, that's a third angle that has the same terminal side. Alright, but this time it's a negative, and that angle would have a measurement of negative 260 degrees. Okay, those are called coterminal angles. You will notice a pattern here. If I took 100 and added 360, so I added a full circle to the angle, I got a coterminal angle. If I took 100 and went the other direction, so I subtract 360, negative 260 is also a coterminal angle. So to find coterminal angles, all you have to do is add and subtract full circles. So either 360 degrees or 2 pi radians. Right, so if we look at these examples here, if I have a 330 degree angle, to find coterminal angles, one time I'm going to add 360, and then I can also subtract 360. So 690 would be a coterminal angle, alright, and negative 30 would also be a coterminal angle. Alright, we can do the same thing with radians. So here I have negative 13 pi over 18. On the one hand, I'm going to add 2 pi, and then I'm also going to subtract 2 pi to get my coterminal angles. I'm going to show you here how I'm doing these calculations with radians. So I'm going to ignore the pi's, and I'm just going to type in negative 13 over 18 plus 2. Alright, so I get 23 over 18 as the answer, and then I'm going to add the pi back in when I write my answer. So my answer is 23 pi over 18, and then I'm going to do the same thing, subtracting 2 pi. So negative 13 over 18 minus 2. Alright, this time I get negative 49 over 18, so I'm going to make it negative 49 pi over 18. So you get to kind of treat the pi like a variable, like an x. Just add and subtract the numbers and then add your pi back in when you write the final answer. Alright, last thing we have to talk about are reference angles and reference triangles. So what you need to know is when we have an angle, I can draw what's called a reference triangle, which means I'm going to go from the terminal side and I'm going to draw a line straight down to the x-axis. Always to the x-axis, never to the y-axis. Alright, and what I've done now is I create a right triangle. Alright, and this angle right here at the origin to the x-axis, that is called a reference angle. Alright, we will talk about reference angles. We'll use reference angles a lot later in the semester when we talk about unit circle and all kinds of things like that. But right now you need to be able to find them. So if this blue angle that I drew, let's say it was 120 degrees. Alright, I would need to find this angle, this little red one, the reference angle. Alright, and it's the difference between 180, because that would be a straight line. Right? If I went from here all the way down, that would be 180. Alright. And so the reference angle would be the difference between 180 and 120. Alright, so I would have a reference angle of 60 degrees. Okay. What you need to know about reference angles, they are always positive and they are always acute. Okay, so positive and between 0 and 90. Alright, we can't have a reference angle of 100, can't have a reference angle of negative 40. Always positive, always acute. Alright, and the easiest way, I think, to find reference angles, we're always drawing them to the x-axis. Okay, so they will always follow the same pattern. Okay, so if I'm in the first quadrant, then whatever the angle is, that is the reference angle. Okay, so if this were my angle, if this was a 40-degree angle, 40 would also be the reference angle, because if I draw the triangle, the angle and the reference angle are the same thing. Alright, so in the first quadrant, the angle is the reference angle. They are the same. Okay, in the second quadrant, it's always going to be 180 minus the angle gives me the reference angle. Okay, because here's my angle, my reference angle is to the x-axis. It's the difference between a straight line and the angle that I have drawn. In the third quadrant, it's going to be the opposite. It's going to be the whole angle, and if I subtract 180, that would give me the little piece that's left. So in the third quadrant, it's going to be the angle minus 180, gives me the reference angle. And in the fourth quadrant, the reference angle is the difference between the whole angle and a full circle. So in this one, it's going to be 360 minus the angle is the reference angle. Okay. Now, this chart that we drew, so theta is the reference angle, 180 minus theta, this works for positive angles that are less than 360. Okay, so if you have a positive angle that's less than 360 degrees, you can just use these 4 rules and you're good to go. Alright, but what happens if you have an angle that doesn't fit those rules? Alright, well, if your angle is greater than 360 degrees, then it's pretty easy. All you have to do is subtract a circle until you get one. So if I was dealing with a 520 degree angle and I was trying to find the reference angle, the first thing I would do is subtract 360. Alright. So 520 minus 360 gives me a 160-degree angle, and now I can use the rules, all right, find what quadrant that would be in and use that rule to find the reference angle. So if it's greater than 360, all you need to do is subtract 360 until you get an angle that is less than 360, and then use the same rules. All right. If you have a positive angle, or a negative angle, a negative angle, okay, then what you have to do is flip the rules, because we're changing the direction, so the quadrants are going to flip. So the first and fourth quadrants would switch, and the second and third quadrants would switch. So if I have a negative angle in quadrant 1, I'm actually going to use the rule from quadrant 4. Alright, and if I have a negative angle in quadrant 4, I'm going to use the rule from quadrant 1. So the quadrants are going to flip. The same thing. This one would be theta minus 180 for a negative angle, and this would be 180 minus theta. Okay, so if it's positive, you would use the original ones that we wrote out in blue. If it's a negative angle, again, you're going to use the ones that we wrote out in red. Alright, same thing with the negative angles. They have to be less than 360. So if you had like negative 520, again, okay, just like we did with this example, if I had negative 520, alright, this time I would add 360, right, so that I get negative 160, and now I can use my rules. Okay. Alright, so let's do some examples. So here I have a 385-degree angle. That's more than a circle. So the first thing I'm going to do is subtract 360. Alright, 385 minus 360 gives me 25 degrees. Alright, this angle is in quadrant 1. The rule in quadrant 1 is that the angle is the reference angle. So 25 degrees is the reference angle for that one. Alright, here, again, I have more than a circle. Alright, so, and it's negative, so the first thing I'm going to do here is add 2 pi. Okay, so negative 8 over 3 plus 2 will give me negative 2 pi over 3. So now I have something that's less than a circle, and I can use my rules. It's in quadrant 3, so remember, if it's a negative angle, though, I'm going to flip-flop the rules. Okay, so the rule for here would be pi minus the angle. Alright, so normally it would be 180 minus the angle, but we're dealing with radians. So when I do this calculation, though, I'm going to take the absolute value. So I'm going to ignore that negative part, and I'm going to do pi minus 2 pi over 3, alright, which gives me pi over 3. So the reference angle here is pi over 3. If I drew the triangle, alright, this angle right here has to be equal to pi over 3. Alright, sometimes you'll be asked to find the reference angle and it won't be drawn for you. In that case, you're going to need to go ahead and draw the angle. Alright, so draw the angle before you find the reference angle. So negative 665. I know that's at least one full circle. Alright, and negative, so I went down. And then after the full circle, I still have another 305 degrees to go. So that would be 90, 180, 270, and then 305 would be somewhere in there. Okay, so that's what my angle looks like. Alright, so I know it's in quadrant 1, so I have negative 665, alright, and I'm going to use the rules for quadrant 1, but first I need to make it less than 360. So I'm going to add a circle, and that will give me negative 305. Then for a negative angle in quadrant 1, the rule would be 360 minus theta. Alright, so again, I'm going to take the absolute value, so 360 minus 305 would give me 55 degrees as my reference angle.